So with our first year projects, there's a lot of design that you have to do. There's a lot of computer assisted design, the CAD on Onshape, Fusion, SolidWorks, whatever CAD software you use. And the tendency is to lean towards 3D printed designs for our projects. 3D printing is an awesome tool, it's powerful, it's quick for most products, but when you're trying to print something this big, this large, it takes a long time. This is an example of a base from an old project. As you can see, there's alignment holes for a variety of parts that go into this base, but this entire base was 3D printed. It takes about 7 hours to print this on our bamboos, which is the fastest printer we have in the IC. If you're using a smaller printer than the bamboos, this will take about 8 to 10 hours to print. Well, I could leave that overnight to print. The longer the print, the more likely there is to be a failure. This print can warp off the plate. There can be a failure somewhere mid-print. As it's printing, that could make it fail. There's a lot of options for failure the longer you go with long prints. To make it easier on the IC and make it easier on yourself to get your base, get whatever it is you want developed quickly, you can resort to laser cutting. Laser cutting allows us to make parts a lot faster than 3D printing. So this base that I'm holding right now is purely laser cut, so the top can come off, the sides are all glued in place. There's alignment holes on the bottom, the same way that the 3D print has. There are small 3D printed parts in this base, but these parts took a lot shorter amount of time to print because they're much smaller than this big base. The overall base was laser cut and took about 10 minutes to laser cut and probably about another 10 minutes to glue it all together. So overall, you have about 20 minutes of assembly for this base, not including these small 3D printed parts, versus the 7 to 10 hour print that you have for this big overall 3D print. So the goal of this video is to show us how to go from a long, lengthy 3D print to a laser cut part that still has the same features as that of the 3D print, but is much quicker to make, and you can make it faster, and then if there's errors, then you can remake it very quickly and not have to wait 7 to 10 hours for this. So again, the idea of this video is to show us how to go from a 3D printed product to a much faster laser cut product.
So like we saw earlier in the video, 3D printing is great and it's a powerful tool, but also takes an extreme amount of time if you're trying to print large objects. For our semester projects here in first year, there are multiple times where we need to make a base for the project, and printing that base takes a lot of time, like we said earlier in the video. To make it faster to make bases, we can use laser cutting and assemble a box that represents the base you want. To do that, you can go to Makercase, so go to Google, type in Makercase, click on this website right here. What this website is, it's a website that auto develops boxes made out of wood pieces that can be assembled. For this example, we're going to do polygon boxes with 3 or more sides. Click on that. We now open the tool that lets us kind of mess with the box and design it to be what we want. So if we put in 10 sides rather than 5 sides, we'll see the box preview update. For this example, I'm going to do 14 sides of the box. I'm going to change my size to be the outside diameter, make the outside diameter 10.5 inches, and then make the outside height 2.25 inches. Again, this is purely for example. There's nothing correct about this box of base that I'm building. It's purely for example in the video. We want to make sure our material thickness is 1/8 inch, not a quarter, not 3/8, not half inch. You want 1/8 because that's the width or the thickness of the plywood that you're given and that you will use in the Innovation Center to do laser cutting. We want to make sure it's closed, so we have a lid to work with, or a top to work with. So if it's open, you can see that we just have a empty box with no top. So we want to make sure it's closed, so we have a top to work with. And then we want to put fingers on our joints so that we can assemble it easier. And we'll make our finger size just a little bit bigger, 44.25, so 0.4425. So again, this box is purely for example. There's nothing inherently correct or incorrect about this box. You can mess with the dimensions and get the dimensions to be what you want. But once you have a box that you're happy with, you can click on download box plans. I'm going to disable the panel labels So where it says top, bottom, side 0, side 2, side 4, those are the panel labels. I'm going to disable those. And I'm going to download a DXF so I can import this into Onshape and actually manipulate the box and add some extra features to the box that I may need for my project. If you don't need to edit the box in any way or the base in any way, then you could take this plan right here to the laser cutter and cut it out as it is. But let's say you want to add a hole in the middle of this plan, in the middle of this top piece, for a stepper to fit through or something to fit through. So we'll take it into Onshape and we'll add that hole. So we'll download the DXF. It's now downloaded into my downloads as box.dxf. I'll go to Onshape, which I already have a tab open. So this is just Onshape. I'm going to create a new document. Call it Makercase video, just because that's what this video is. We'll come down here to this plus, where it says Insert New Tab. We'll click on Import. We'll navigate to my downloads, which is most likely where your box plan is downloaded to. We'll click on the box.dxf and hit Open. It'll import, and then you should have a tab populate down on the bottom that says box.dxf. So there's our plan from Makercase. So now to bring it into actual Onshape so we can start manipulating it, we'll go back to the Part Studio 1. We'll do a sketch. Choose the front plane or top plane, whatever plane you want. I usually do the front plane. And then we'll go up to the top where it says Insert DXF or DWG. And then we'll make sure we're on the current document. And we'll click on box.dxf. Hit that check. And now our plans for our box are brought in to a plane in which we can edit them. So we'll hit the check on the sketch 1. And now we'll start extruding these to make them actually three-dimensional. I'm going to hide the front, top, and right planes just because they're not in the way. So I'll hit these eyeballs right here to hide them. And then I'm going to start extruding these plans to make them three-dimensional. So I'm going to hit Extrude. I'm going to click on the first side, the first top. On the depth, I'm going to change that to 0.125, which is 1/8 of an inch. And hit check. You'll notice that the rest of the sketch is now hidden because Onshape thinks we're done with it. Just turn it back on by showing sketch 1 because we're going to continue extruding. I am going to come down here, click on part 1, right click and rename it and just call it top. And then I'll come over here again and I'll extrude the bottom. So I'll extrude again, click on this, 0.125. We're making sure we're doing a solid and new, so we're making a new part, and hit that check again. And I'll come over here and rename this to part 2, or part 2 to bottom. And then I'll do it again. I'll do one more extrude for all of these sides down here. So I'll do an extrude again. I will click and drag. And now you see all these are now being extruded. And again, we're making sure to do solid new. So they're all unique parts. They're all individual parts. We'll make the depth again 0.125 inches because again, the plywood is 1/8 of an inch that we have in the Innovation Center for you to use with your projects. So once we have all of that, we'll hit the check. And then I'm going to go through and just rename them all to side 1, side 2, side 3, so on. Side 2, so on. Once you have them all renamed to whatever you want, I'm just going to change the color of them to kind of more simulate the wood color of the plywood. So I'm going to highlight them all. And notice that over here in the parts list, they're also all highlighted. So I'm going to right click on any one of these. I'm going to do edit appearance. It should say edit appearance for 16 parts. And we'll just change it to be this color, which to me looks like plywood. It can be whatever color you want. It's just, you don't even have to do this part. It is just me changing it to be the color of the plywood just to get a better view of what it will look like. And now, just to clean it up, I'm going to turn the sketch 1 back off. And so now we just have our nice extruded parts of our box. So again, go through and change all these names of part 5, part 6, part 7 to side 3, 4, 5, and so on. I'm going to shift over to another Onshape document where I already have those already named. So I'm going to go up here. And again, I already have side 1, 2, 3, 4, all the way down to side 14. So once you have your parts brought in, let's say that we want to add a hole right in the middle of the top piece. Because again, you cannot add that hole in Makercase. Makercase only gives you these parts to laser cut. It does not let you edit it. It does not let you add a hole or features on the parts. So to say we want to add a hole, we'll do a sketch, click on the part we want to add a hole to. We're going to add a circle, but you'll notice if you try to add a circle that there's nowhere to snap to. Onshape does not see the middle of the top of the board here. So we're going to add some features so we can find that middle. So I'm going to hit line rather than circle. So I'm going to go from circle to line. I'm going to zoom in to the top of the board here. You'll notice that it is trying to snap to the middle of this line. I can see that this top piece is the top middle. So I'm going to snap to that, start my line. I'm going to go straight down to the bottom middle. So again, you see how it snaps, that little square pops up. That indicates that that is the midpoint of that bottom line, and that bottom line is in the middle of the top in this direction. So there's my line that divides the top into halves, left and right. And now we're going to divide it into halves, top and bottom, using our line again. So come up here, do our line. On the left side now, go over to this edge, which we can see is the middle, kind of between the top and bottom. We're going to zoom in just a little bit to make sure that it snaps to that vertex, not right there, because Onshape is just finding features to snap to. So we're going to make sure we zoom in and click on that vertex of the edge there. And then we'll zoom back out. And then we'll go over to the right side. And then zoom in again, make sure we snap to that vertex right where the lines meet. And then we'll hit escape to end the line tool. So now we have a nice vertical line which divides it into left and right. We have a nice horizontal line that divides it from top and bottom. And so now this point right where those two lines interconnect or intersect is the midpoint of the top of the board. So now we can go up here, do the center point circle. And now we have a snap point to actually start drawing our circle. So we'll click there at that snap point. We'll drag the circle out, and then we'll make the circle a 1.5 inch diameter, just for example. We'll end the sketch, and then we'll extrude that circle out. You gotta click all 4 quadrants of it. And then we'll make it to remove. So right now it defaults to add. We want to remove. And then we can just leave the 1 inch alone, because it's saying cut 1 inch through material. The material is only an 1/8 of an inch thick, so the 1 inch will cut all the way through. So we'll leave the 1 inch alone, make sure it says solid, remove 1 inch, and then check. So now we have the plans from Makercase, but we also have them edited to include whatever features we want. Like in this case, this circle is what we wanted. An additional thing you can do after this is you can also assemble it in Onshape. So if you want to say assemble it, because a part of it, the project documentation is assembling your 3D models. So I will show you how to assemble it like this, but I'm going to go back to the box parts in a second and say, let's say we want to laser cut this. Let's say this is ready to laser cut. We'll go to insert new tab. We'll do a drawing. We'll leave it as the inches. So there's inches and millimeters. We'll leave it as inches. So hit OK. We now have our nice drawing template. I'm going to hit close on this for a second. Close on the insert view. I'm going to rechange, or I'm going to edit the size of the template. So I'm going to hit this button here. I'm going to right click on sheet 1, go to properties. This sizing, I'm going to put down to custom. I'm going to make the width 24 inches and the height 12 inches. I'm doing that because the boards that you're generally going to be cutting on with the laser cutter are 24 inches by 12 inches. So I'm going to make the template 24 by 12 as well, just to kind of mimic the boards we'll be cutting with. So once you do that, 24 by 12, hit the check. Go back up here to Insert View. Click on Insert. And then we'll start bringing in our bottom. Make sure it's 1:1, not 1:4. So it's the actual true scale. So we'll bring in the bottom. And then we'll hit Escape. Ignore that. We'll hit Insert. Click Insert again. We'll go down to where it says Top. So we'll bring in the top piece. Again, make sure it is the front view and 1:1, which 1:1 just means that it is the correct scale. So it'll laser cut out the correct size that you want. So we'll put it there. And then hit Escape. So now we have our bottom and our top. And to get rid of the naming box down here, you can just come in here and manually delete all of that. So I'm going to move the top for a second, highlight that, and then bring the top back over. That way, when we put it into the laser cutter, it only cuts out your top and your bottom and not the naming box. So this is the top and bottom. We still need to add another drawing for the sides because there's no room on this for the top or for the sides to go. So we'll come back, insert another drawing. We'll do the same thing. I'll close out of this for a second. We're going to resize the template. Again, where it says size A, click on that, go down to custom, make it 24 inches wide by 12 inches tall. I'm going to go ahead and just delete the box in the right corner. If you're actually doing an engineering job where you're providing drawings of a project, then you want to have that box there because that is where you record your name, your company, the revisions, and so on. But for this, for laser cutting, we don't need it. So go back to Insert View again, Insert, and then your sides. And then since all the sides are the same, you can just copy and paste them 14 times because there's 14 sides. Let's say that you added a hole into one of the sides, and you would obviously need to bring that side in with the hole. But since all 14 sides in this example are the same, you can just copy and paste until you have the 14 sides on the template. Once you have these templates laid out with the 14 sides and the top and bottom, then these are ready to be laser cut. To get these into PDF form, you can right click on the drawing you want to laser cut, export to a PDF, and then that is ready to be taken into Adobe Illustrator and sent to the laser cutter. Now let's say we want to assemble it like this for the project documentation. To do that, I'm going to go to Assembly 1, which is my bare assembly. There's nothing in it right now. I'm going to go to Insert. I'm going to insert the bottom first. Put it wherever you want. For now, I'm going to hit the check mark. I'm going to do some work with the bottom very quickly. I'm going to click on it. Just click on the bottom. You see these axes pop up. I'm going to click this back axis on this with that circle with the two lines popping out of it, which allows me to rotate it. So I'm going to rotate it 90 degrees just so it's sitting flat. And make sure it says 90 degrees. You can also just type in 90. And then when you have it where you want it, click. And now that bottom is sitting at 90 degrees. I'm also going to right click on it and just fix it in place so the plate or the bottom can't move. Now I'll go back to insert. I'll start bringing my sides in. And again, in this case, since all 14 sides are the same, it does not matter which one I bring in. I'm just going to bring in side 1 over and over and over. Again, if you made a change to one of the sides, like if you added a hole in side 12, then you want to make sure to bring side 12 in. But since all 14 sides are the same in this case, I'm just going to bring in side 1 14 times. So I'm going to bring it in. I'm going to put it somewhere close to the board, hit the check mark, and I'm going to mate it. So I'm going to go up here where it says fasten mate. I'm going to zoom in to the side. I'm going to click on the left bottom edge here and make sure that mating circle is kind of on the same plane. So I'm going to click on it where it is. So that's our first mate. And I'm going to come back to the box, the plate. And I'm going to click on, I'm going to look at this section, this cutout right here, because we're looking at, we have one tooth here, which will go in this section. And we have this tooth, which will go in this section. So I'm going to zoom in. I'm going to click the bottom section of this mate of this area. Make sure that circle with the green, red, and blue is planar to what we're looking at. So make sure it's not sitting like that. Make sure it's sitting like this, where it's planar on the same plane as where we want to mate it. So click it. We'll bring in our side. We'll see the side's not exactly where we want it, so we can come over here and do reorient. And then flip it around. And now it's where we want it. Hit our check. And then we can do the same thing. Bring in another side. Do a fasten mate again. And do the same thing. Repeat the process. We see that they're nicely snugged in there. And we'll just keep doing that all around the perimeter until we have all 14 sides of our box on. So I'm going to do a fasten mate again. Again, reorient, flip, and hit check. Sometimes you put a side on and it will just go exactly where you want it, so you may not need to do the reorient and the flips. But if you have the issues where you put it where you think it needs to go and it does not line up, then you can do the reorient and the flips. I'm going to do one more, and I'm going to jump to the example I have that already has them all assembled. So we'll do a fasten mate again. And you just do that all the way around. So now we'll jump to the example where I already have them already assembled. So we have this with all 14 sides assembled. And then we'll bring the top in. So we'll go to insert, scroll down to the bottom where it says top. Put the top wherever you want it. Hit the check. We're going to do the same thing with the top that we did at the bottom. We're going to click on it. This back rotational axis, we're going to click it and drag until it gets to 90. When you have it at 90, click off of it. I'm then going to manually drag it and kind of line it up, and then see that this tooth right here needs to line up with this slot. So I'm going to do a fasten mate. Zoom in on this tooth. Again, I'm looking at it. I can see that based on how the top is lined up, this tooth will line up with this slot. So I'm going to zoom in on it, onto the front of the tooth, and make it so that the alignment circle, the mate circle, is on the bottom middle of the tooth. Click on it, and then come back to this edge to the side, and we're make it so we're clicking on the top middle of that slot and make sure that the alignment circle is where you want it, right where it is in this picture. Click, the top will move over, hit check, and now you have a fully assembled base that is from Makercase that is easily to laser cut and is a lot faster to manufacture than waiting on a long 3D print. In this example, all I did was add that circle in the top, but if you wanted to go back to the side, add features on the bottom, add features on the sides, add more features at the top, you totally can. This is a very easy way to kind of mirror and mimic the plans that you have for a 3D print, but makes it much easier and quicker to make rather than waiting for a 3D print to be completed printing.